Hey, what's up, Ziguanas? This is day 14 of the 30 days of Z coding challenge already. Join me one more time as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. Yeah, already 2 weeks. Time flies when you're having fun. So for today, I have switch on the menu. That's where I stopped yesterday. So let's do some switching in Zig. What they say about switch? Do they explain nothing before the code? Everything is in the comments. Let's start here. Yeah, here I don't need these things, and let me delete this from yes. Oops, deleted too much. Okay. No, I actually want this to be inside of the main. Okay, so we have two constants, a and zz. They are both u64s, different values. Okay, then let's see what they, oh, this is a huge switch, and then they try at the end something. Actually, let's comment out, not comment out, let's copy the comments as well, so that I have everything in the same place. And let's try to understand what they want to do. First of all, let's read a bit. All branches of a switch expression must be able to be coerced to a common type. Okay. So common type, I believe they want to say the same type, or maybe not exactly the same, but compatible maybe. I don't know what they exactly mean by common type, but we will see, I guess. Branches cannot fall through. If fall through behavior is desired, combine the cases and use an if. Okay, so I actually like this. I don't like the languages where you actually have this fall through. I never liked it. Okay, let's see what they want to do. So they have A, Z, Z already defined. This is B, which will take something from the switch. So it will get the value from the switch. And we see it switches A, which in this case is 10. Oh, they jump straight into some more advanced examples, but it's okay. Let's see. Because like I said before, these Zig docs are not so detailed, so they kind of jump over the things, which is fine by me because I do have experience with other languages before. But again, this is maybe not something convenient to some beginners. Okay, so let's see. Multiple cases can be combined via a comma. Okay, so if any of these three, the switch will return the value of 0. Then let's see, ranges can be specified. Again, they use 3 dots. I'm curious to see because I know that when I tried to do ranges somewhere, like in an expression, they didn't work. So this broke the code. If I use 3 dots, I didn't figure out why. Maybe they have to be used in switch or something. I'm still not sure. But let's see if it will work here. So ranges can be specified using the 3 dot syntax. Okay. These are inclusive of both. Inclusive. That's interesting. So usually this is not inclusive in slices, for example, in many languages, but here it is. Okay, so from 5 to 100. So basically they just keep 4 here, right? So 1, 2, 3, and then they jump through 5 up to 100. They will return 1. Okay, then the 13 branches can be arbitrarily complex. So what they say here, they say if it's 101, they created a label block, and inside of that block, what they have, they define C, which is 5, U64, and then they break the block. So basically you get this value from here over here, and that will be the output of switch. And what will be the value? So 5, this is 5, right? So 5 times 2, 10 plus 11. Okay, so 11. They have even more branches. Oh, they are trying to do so many things at the same time. So actually, let's comment out part of it because I want to go slower a bit through all these. So let's do this, and then let's actually try this. Yeah, let's leave these 3 are enough, let's say, and then I'll just print B. So I will not try it. I will just print, and we want to see B, right? So B equals, oops, whatever it is. Let's run. Unused. Okay. So I don't need it for now. This is thing I can do. Yeah, I forgot. I have to handle all the possibilities. So I have to have the default one. That's probably where I stopped, the else. Okay, I guess else should be enough. Let's see what they say. Else branch catches everything not already captured. Yeah, should be enough. Else branches are mandatory. Yeah, unless the entire range of values is handled. So I guess in this case, because we switch A, and A is U64, so basically it can be any number that is from 0 to, I forgot what was the largest 64-bit number, but it's a big one. So I guess if I were to, I will try that later, if I set up something like a smaller type and I just cover, for example, if I say U2, which is 2 bits, so if I had a number from 0 to 3 covered, will this work without else? I just want to try that next, but let's try first now. So now I have this else, and let's see what we get. B equals 1. Okay, let's see. So if A is 10, that falls into this range here. So it looks like this is working here in switch, and I couldn't use it. So let me just try one more time here. So I will copy paste this one here just to see if that's what I had before. And let's do any here just to see. I think this didn't work when I tried a few days ago. Yeah, doesn't work. So there is something that I'm missing. So it can be used here to generate the range of possibilities for the switch, but you cannot just use it anywhere you want. So like I can do a literal, for example. So this one doesn't work. That's cool. Okay, back to their example. So when A is 10, it will fall into this range, and then it will be 1. B will be 1. And if we change A to, let's say 2, should be then 0, right? So let's try this branch. So this is just testing multiple cases at the same time, but not as a range, just like separated with commas. And it is 0, okay, as expected. And now let's try 101, and I think it should be 11, right, if I calculated everything correctly. 5 times 2 plus 1, yeah, should be 11. Yeah, so 101 will cause this block to execute, and then because it's labeled, it will provide this value here, which is 11. Okay, makes sense. Now let's see the next example. This one here. What they say, switching an arbitrary arbitrary expressions is allowed as long as the expression is known at compile time. Okay, so they this is interesting that they do ZZ. So in case of ZZ and this block, so they are kind of combining this one with this one here. So it is allowed as long as the expression is known at compile time. Let's see what they have here. They have constant, so compile time, constant compile time. Adding two constants should be known at compile time. This here ZZ was, yeah, I forgot. I also have to uncomment this part here. Also constant. So basically, they have all constants here. And it should be 105, right? Here as the result that they they use this as, yeah, so they don't return, they return 107, but they actually take this expression as one of the cases for switch. So basically it will be, if it's ZZ, which was, well, I forgot, 103, and in this case, what I said, 105. So if it's 103 and or 105, it should return 107. So let's do that. Let's do 103 first, which should match ZZ. Yeah, 100. Wait, why 103? They return. If it matches 103, this is a different case. Okay, my bad. So they are kind of like merged. I oversaw this arrow here. So it's not like ZZ comma and then this expression, what I initially thought, but they're actually like this. So if it's ZZ, which is 103, it just returns ZZ, which is, they're just like doing this like as two examples for kind of the same thing. Okay, so because I set A to 103 and ZZ is also 103, so if it matches 103, it will just output the same number, 103. Now let's try this one. So if it matches 105, we should get 107, right? So let's try 105 here. Yeah, 107. And can I do what I actually thought it will do initially? So can I do this? Can I say ZZ or this value of this expression in the same range as two cases? So basically like here, if I were to combine this one and basically this one. But I'm just now using it. So here it was like an output. Here, because they already show that you can use it also as the input right into switch. So I just want to combine. Let's see if this will be okay. Yeah, it works. So now I guess it should be also 103. So if I do 103 or 105, I should get 107. Yeah. Okay, nice. And I think this is the last one, right? The else we already explained. Yeah, we went through all of them from this part. Okay. And I'm glad that I did blocks before because they are using it. So I wouldn't like to stop here and then skip over these few cases. Okay, let's do the next one. Switch expressions can be used outside the function. Okay. What they do here. So they switch built-in target OS tag. Okay. And they say, what they are using. So let's do this, and they say outside of a function. So let's just do it outside of main here. Let's create this switch, and then let's just try to print it out. So OS MSG, and let's see built-in target. I will need that one imported. So this one. Okay, and then I want to print OS underscore MSG. And let's comment out these few things. Oops, MSG. And it was a string, I think it will break for sure. Yeah, this was what I wanted to say. And formatter without specifier, yeah. So let's do string. Okay, we found a Linux user. So let's go back here. They take this built-in module and then, or however they call them in Zig, modules or something like a module, and then they switch, they go deeper. Inside of this, I guess it's a struct or something like a struct. They go deeper into .target.os.tag, and they switch. If it's Linux, they say we found a Linux user, else not a Linux user. So obviously in this case, these guys zig-play.dev, they are using Linux on the backend for this one to run. Nice. Okay. Then let's see. Yeah, the point here was that it can be used outside of a function. So I did use this one outside of main and it worked fine. Inside the function, switch statements implicitly are compile time. Aha. Evaluated if... Aha, there is an if. Okay, I stopped too soon. If the target expression is compile time known. Switch inside the function, okay. Built-in target OS tag, so basically the same thing, right? Yeah. So they switch it for this value, and then they have this processing here. Let's actually copy paste. And then I will read it here. It's a bigger for you guys to read. Larger. Let's do this here, and let's print outside of the switch the so I did not assign it a value. That's why I stopped, because before I had this thing. So I wanted to print something. Then I found that they are not assigning this to anything. So let's assign it to something, let's say a result. And then I will say R here. And let's now see what they want to do. They switched the same thing like before, but this time inside of the function, because I'm in main. They try to see if this is the tag of the operating system. And then they say on OS other than, how do you pronounce this? Fuchsia. I don't know how to pronounce. Block is not even analyzed, so this compile error is not triggered. Aha. Okay. So this is not even analyzed, this block, on an OS other than Fuchsia, or however you pronounce it. So it will not... I guess this is like raising an error, compile error, because I still haven't touched error handling in Zig. I guess this is a kind of error handling, error raising an error. Okay, and else it is, this is like an empty block, so it will be void, or what will be. So we'll see here. Let's see if I just type penny here, what it will do. What do they say? 61. Yeah, it's void. Okay. I mean, I can put anything here. It doesn't matter. Like, this is important thing, what they explain here, that this is not going to even compile. Like in the binary, this will just like be skipped, and it will test this OS during the compilation time, and it will not do this. Okay. Then let's see what's next. Did I miss something? No. Okay. Then what they say here, switch can be used to capture the field values of a tagged union. Okay, so I did unions. Or I can at least understand them. Modifications to the field values can be done by placing a star before the capture variable name, turning it into a pointer. So you turn it into a pointer and then you can change it. Okay, let's see the example. Again, a big one. Let's see if they all do work together. So I was about to just copy the part of it, but maybe they're related. Let's first see what they do. So first of all, they create a struct, point struct with x and y, both U8s. Then they create a union here where they, let me zoom in a little bit. It will jump, I think, if I zoom. Let's try. Yeah, it jumped way over. Okay. So hope you guys see. I can actually zoom like this. I can do this. Not, it doesn't look nice. Okay. So anyways, let's continue. So item is a union which is tagged with this enum. Not actually this one. They're not tagging it. It's just like generic enum. And then here they have these fields A, B, C, D, E in a union with different types. One is U32, one is the type of this struct, this one is void, and this is U32 again. So they have several different fields. Then what they do, and switch they, okay, so they are related. I'll just copy paste because it's more visible. The font is larger on, let's actually copy like this, on this, in this IDE. Now it will be different if I run it in the main. How they run it in the function? No, so let me run it outside of main here, and then I will just print something. I still haven't looked the code, don't know what I want to print, but let's, and let me delete these things so that it's closer. Okay, now let's go and continue. So I went through this part. Let's see what they do next. They set up a variable A, which is the item, and they activate the C type of a union, and they set the value of the point, which is the type, so it is okay, and then they generate a point here on the fly, which sets the x and y to 1 and 2 respectively. Then they do a switch finally, and what they say, switching on more complex enums is allowed. Okay, so basically they switch A, which is of type of this item. Then let's see what they use for the first time these capture groups. So I mentioned them before that I didn't understand what they are. I mean, I've just seen like something like this in some code before. I forgot where at the beginning, some like second, third day, and I didn't know what this is. And then I stopped. Then I did a research, and I just like found out that they are called capture groups. But I already moved on to the next thing, and there was no specific, let's say, chapter of Zig docs that covers them. So I couldn't just like analyze them and how they work. So that's why I just moved on. But now I can use them because I covered all these other things. So at the moment that I was seeing them for the first time, I didn't know, I forgot what was it. For example, let's say it was a for loop. I think it was a for loop. I didn't know how for loop works in Zig, and I didn't know what are these. So I kind of like just like decided that it's too many unknowns at the same time. So I moved on to the next topic. But now at least I've covered these. So unions and structs, so I can understand better. Still, I will now for the first time play with these. So let's see how they work. So okay, they switch item A and item E. So basically, in our case, it is item C, so it shouldn't trigger this part here. But in case if it were A, then it should be this capture group, an item, which I don't know how this works, so we will see. I will play with them. So actually we can start from there. If I set this A, not to the item C, but to the item A. And let me just see what they have. Aha, they don't. I was about to see if they have else, but they don't because they exhausted everything. But I will comment out these and I will not exhaust all of them. So I will need an else. And I'll say else, and then I will just say 0, doesn't matter. And let's see here, instead of doing this part here, what I'm going to do is item, oh, it covers A, actually, yeah. So I forgot that this covers A as well, so I can literally do it here. I can just set the value of the A. That's enough, okay. So let's then uncomment. I missed that. I mean, I forgot it actually, so saw it a minute ago and I already forgot that it is covering A as well. So I just need to set this to A. So it is point A, which is U32, so basically it can be anything. So let's see, 1, doesn't matter. And it should trigger this branch here, and it should return this capture group and item, whatever that means. And let's see how that will look like. So if I print out B, what will I get? And I will comment out these. And let's print out B and how it looks like. What did it say? Did they comment it out? No, I wanted to, but I didn't. Able to evaluate comp time expression, cons B equals switch A. Why not initializer of container level of variable must be comp time known. Okay, so let's say const. So that is comp time known. This is a thing because I have it outside of main and I try to print inside of the main, I believe. Okay, let's see what happens here. So now it's item union that is activated for the A, for the first field, which is U32 with the value of 1. So this will match here. And then basically I have this capture group that, maybe it's about because they are different type. So maybe this is the point of capture groups, because A and, no, They are the same type. A and E, right? Yeah. So they're the same type. U32, U32. Okay. And we return the enum value matched. If the payload, so okay, enum value match. So here, this is the enum one. But I don't have an enum now. So what do I do there? Still, if the payload types for both cases are the same, they can be put into the same switch prong. Okay, so at least I understand this part. That's the reason why they can put them in the same switch prong, however they call it. So I would say branch, right? Or maybe there it's a different thing. I'm not familiar with this word prong. What does it mean in English? So let's say branch in my mind. I will just think of it as a branch. Maybe I'm wrong. So if the payload types of both cases are the same, so in this case they are U32, U32, then they can have here the same, they can be dealt with in the same time. Okay. If they're not, then obviously they cannot. But I still don't understand what this capture group does. So they take the item. I would understand if they just say this, but they don't, right? So they... And where is this defined? Actually, this item is with uppercase I is defined here. Then there is no such... Aha, so I guess they are defining it here. Aha, this is kind of like an input. So it's kind of like for item. And then like the item is also an output. Maybe this is kind of like a lambda or something, this capture group. I'm not sure. So let's say zig capture group one more time. Capture the value for something. Okay. Yeah, here it's a bit different. So, okay. So in the union and optional sections of all values captured with the group capture syntax are immutable, similar to function argument. So yeah, it does look something like, in this case at least, as an anonymous function, as a lambda. But we can use pointer capture to modify the original. So yeah, that's what they explained. This captures values as pointers themselves, still immutable, but because the value is now a pointer, we can modify the original value by dereferencing it. And they gave this example. So definitely, I think this is something like anonymous function. So or a lambda, if you will. So for, let's say, this input, which is a byte in this case, they give it a name byte, and they just like say it's a pointer, then they change it in this way. In some other examples, they change it in a different way. So for now, I will think of it as what I just said. So maybe I'm wrong, but it looks like anonymous function to me. So let's say this is an anonymous function. So it will take the item and just return it as it is. I can actually test this very easily. So if I say times 2, I should be able to get 2 here. Yeah, it looks like an anonymous function. Okay. So then let's move on. So if it's item A or item E, and in this case it's A, so I can also switch it to E. It will be the same, no need for that. It will trigger this branch. Then if it's C, and it is their default thing here, and I believe this is now going to break because it's var. Yeah, so let's just try to copy paste. I just want to test my hypothesis that this is happening because this is outside, that this is not inside of the main. So what if I put it in main? Will it still break or it will run? Okay, this is a different thing where 3, oh no, this is there. Okay, wait, what did I do? Ah, okay. Copy paste problem. Okay, it works. Yeah, so then definitely the main, yeah, okay, it makes sense because main will run after compilation. So then if I have a variable, it is okay. But I cannot put a variable outside of the main because that part is compiled. Okay. So, yep, so because, for example, these kind of things, I've never read anything about it in documentation. So it's just like trial and error and memorizing what happened before and trying to figure out. So maybe they said it, so maybe it's my mistake that I haven't read these beginning of docs thoroughly, but I haven't seen it. So now it makes more sense. Okay, so let's now see what they return 6. So B is okay. That was for this case when item C, and it is item C activated. So for this point, and then what they do, they take the point to that item, so the pointer to that item, and then they create a block which is labeled, inside of which they dereference the pointer, right? And the pointer is to the point. This sounds silly. No pun intended. So this is the thing that comes inside. It's a point struct, which has 2 fields. So here they dereference it. Then they take the first field, increase the number by 1. And then, so it used to be 1, right? Now it's 2. And they just return. So basically, that's why I see 6, but it's more interesting to print out the point, this variable where the item A. So this is how they, so because it's so nested, so not even created this directly. It's not created here. They create a point on the fly inside of this item, which is a union type. Okay, so no reference to it outside, but I can try to print the, I mean, it will be 2, but just to play with it a little bit. So if I print A, right, the A should be now showing the point with 2 for X. Oops. What did I do? Yeah, now X is 2 here. That's cool. That's nice. Okay. That is nice. Then let's see the last case, and they covered all, yeah, so because there are only 4 fields here in this union, and this is the last one, so they just say simply if it's D, should be 8. And let's make it D. What is D? Is void. Okay, so let's just say here, so const A, I will comment out this. It can be var also, but let's say const, and let's say dot v, and I believe with void I don't even have to assign. This is enough so that it becomes d, and then we expect to see void and 8. First b is there is an error. Okay, item does not support array initialization syntax. Okay, so it thinks of it as an array initialization here. Let's try to assign void if I can. Fun type. So if I do this, the thing that we've seen before that has the value of void. Yeah, now it works. Okay. Yeah, I literally saw this today, like in the previous example where they did. Where? Here. And I remember it was void. So this is how you can set a variable to void if you want, or maybe, I mean, in this case, I cannot just leave it empty. Maybe there are some other use cases where you can do that. But in this case, this is enough. So 8 is, so item is activated as the part of the union. So that's why here, when I say A equals item D, I activate this branch or this field, not a branch. Then because this is activated, it will return 8. That's why B is 8, because that's the value that we receive here from the switch. And then additionally, when I print the A itself, it will just tell me what it is. So it's an item. So again, still don't understand this part, how this is structured. So main is maybe, okay. So maybe main is the name of the function, because I am running it in main, and then play is maybe the name of the thread or something. I don't know what this play means. Or maybe it's just like in their case, this like zig-play.dev, maybe that's how they set up their runtime, and this is specific to them. Don't know yet. So it will be interesting once I install it on my computer. Still haven't done that, so I'm still running Zig just online. Once I install it on my machine, I'll see how this will look. The same code, basically. If I run it, just a simple code with main, if it will be the same root struct or whatever it is, or not. Okay, let's see what's next here. We finish this one. Okay, these are their examples. ACX. Okay, this is, okay, they are just like trying for their example to go, because in their example, A is a point. So they try to go to the union, take the activated option, or however they could, it's probably not officially called an option. It's C, and then inside of that activated option or whatever it is, they go into the X field. So maybe it's just like proper to say activated field, or I forgot. I literally did like did unions like yesterday or day before, and then I already forgot how they name things. Okay, exhaustive switching. When a switch expression does not have an else clause, it must exhaustively list all the possible values. Failure to do so is a compile error. So that's what they literally did here, because they exhausted all the options of possible values of a union. But let me try, let's first see their example. Okay, this is different than what I wanted to do because it's an enum. I want to do what I mentioned before. I want to, let's first of all delete these So what I wanted, actually I can leave switch, not to print everything. So I wanted to do something like what I wanted to do, I forgot. So I believe I wanted to do, let me see the first example to remember. Yeah, I wanted to make this U2 as a type. Okay, so let's do that. Let's say A equals to U2, and then doesn't matter what I set it to. Hi, Leo. So let's see if I switch A, and if I say if it's, let's say 0, 1, 2, or 3, I will return, doesn't matter what, let's say 8. That's okay. And now let's see if my hypothesis is correct. So can I do this? Basically because this type has only these 4 values, right? So if I say this is unsigned integer with 2 bits, then I have just like 0, 1, 2, 3. And this should be exhausted here. So then let's see if it's going to run, or they don't, the compiler doesn't analyze the type, it doesn't care, it just like, yeah. No, it's a different const b where yeah. So this is what I wanted. Yeah, okay, cool. So it does consider the type. So if I take all the possible values of the type, and in this case it's only 4 numbers, then I'm fine. So then it means if I increase this to 3, it's going to break, because I should have 4 and 5 covered. Yeah. Yeah, nice. This is so, oh, I like this so much. Like, these simple things make me so happy. The way they built the language, like these details. Now I understand why people on Stack Overflow say that they admire the language. I'm just scratching the surface, and I already found these few things that I love. Okay, so I was here. Let's test their next example. Okay, let's do it. Well, I can do it here. Okay, there is a color enum which has 3 possibilities: auto, off, and on. Okay, and then what they do, they create an instance of it. So they create a color const, which is the off, which is the second possibility of this enum. And then they test for auto and on. They don't test for off. So basically it should break, right? So this should break the code. Yeah. So if I just add, for example, else, or if I explicitly say for the off something, then should be fine. So it's okay to be void. So let's say off here. So this should be fine. Yeah, and this is also same basically in this case. This for example. Command server. Yeah, okay. The next thing, switching with enum literals. How many things are left for the switch? Switch dispatch, inline switch prongs. Oh, so many things about switch. let's see how far I will get. So it's already almost 1 hour since I started, so I will try not to go a lot after the first hour. Maybe I'll pause things and then continue tomorrow. So basically I'm here at this point, labeled switch. Good evening, Robert. Yeah, everything fine. I was just enjoying some bits and pieces. So I tried a few moments later. You will see later. You can see. I tried to switch that. Maybe I have it still in the code. No, I deleted it. So I just like created a constant of u2, and I just used the 0, 1, 2, and 3 as values. And I wanted to see if it's going to compile or it's going to say like you haven't thought of all the possibilities, and it did compile. So it even considers the type, which is very cool. That was my like joy for today, Saturday night fun. How are you doing? Let's see. Yeah, I was here. So labeled switch. When a switch statement is labeled, okay, here they label it as W. It can be referenced from a break or continue. Okay. So basically because of the code block, right? So it's like any block, you can break it if it's labeled. Will return a value from switch. Yeah, like in the other examples. A continue targeting a switch must have an operand. So it's a bit different. When executed, it will jump to the matching prong. If the switch were executed again with the continuous operand replacing the initial switch value. So this kind of sounds confusing. I guess I will see it in action and understand what they wanted to say with this. Okay. So let's do this. And they don't test it. Let's see if I copy this part, do it here. And let's now analyze. First of all, let's try to see what they do. So they have this, this is also cool. This is, I was about to say something that I see for the first time. Maybe I saw it before, but I don't remember. Or maybe I've seen it, but I didn't understand. But what I think now, this is because it's a literal, it will be comp time int. And then they convert it to, they cast it with as to i32. So that it's a different type. Then they switch it. And this is the branch that will, this is continue. Okay, let's see. This is already a psychedelic part of it. Let's see what they do. So this is going to be triggered for sure. And then they do this. And they, no, they do continue here. Okay. I thought they are going to create another block here. So they're not, they're just like continuing here. And they use the value after. So they bring this value back and then continue. So I will definitely have to run it to understand how this continue works. Then they have another continue. Yeah, why would they do something simple first? And then they have another option here, which is 1, where they just return. And then they have else, which is unreachable because they return, they use return here, right? So that's understood. And let's see what we have. We have it 5, so it should trigger here. So I guess, if I understood correctly, let me see just what you say, Robert. Doing great, great to hear. Switches in Zig are neat. Oh yeah. Especially adore inline else cap. I still haven't reached. I think that's the next topic, the inline switch. So I will understand your comment a bit later. The type change is because it's labeled switch. It needs runtime non-size. Thanks for the clearing these things. Okay. of the parameter inside the switch will continue. You rerun the switch with new value. With new value. Okay. So rerun with continue. You rerun the switch with the new. So I thought it's going to continue and run it from here, but you kind of run it then with this value. Okay. Okay, that's so cool. And so confused, so this will take me some time to get used to. But it sounds so cool. So at this moment I cannot even like imagine what are the possibilities and how you can optimize the code with this. But probably there will be like a lot of these aha moments in the future when I actually play with them. It's for state machines. Parsers, producers, bad machine code. Oh, that's so cool. Yeah, so it's very, very optimized for the low-level things, which I haven't touched for years. So that's even one more reason why I enjoy this. Okay, so let's see. Let's run this. So let's run this and let's print what we have here. So this is a labeled switch. I have to assign the value because if I run it, I will not see anything. There are no prints here. Let me see what I will get if I run this. Will it, first of all, will it compile? Should. Yeah, compiles but doesn't return anything. So let me assign this to something if I can. So let it be here. So let it be a const, whatever, r equals this. And then I can do r and whatever it is. I don't know what it is. Still haven't followed through all the branches. I just want to see the result first this time and try to figure out the logic. There is an error. Okay, I think this is here. I forgot to close the switch. Or because I have print after. And I don't see anything. Why? Let's try to figure out why. So it starts with 5. So it will be the case here, which then continues and it changes the value to 4, which, if I understood correctly, reruns the switch. Then it should come here. So this is now 4. And it asks if 4 is greater than 3. It is. So it will continue as 2. So it will rerun again as 2, if I understood correctly. Then this is going to be 2 again. Tests here, it's not 2, so goes here. If it's 3, it's not. Then it breaks here because it's 2, right? And because it breaks and it doesn't return anything, that's why I guess I don't see anything. Not sure. Hi, Nopanon, I hope I pronounce your name well. Welcome. Yeah, it looks very interesting so far. So I'm just like 2 weeks into Zig and I already start loving it. Okay, so let's see here. If I break and if I here put something like, let's say 10, will I see 10 at the output? No, I still don't see it. So why I don't get anything here? Let's try to simplify this just to see if I understood correctly. So instead of this, I will say for this case here, I will do 100. Doesn't matter. Just to have something, and then what they say if it's 1. So what is covered? 1, 2 to 5, and else unreachable. Okay, let's run now. Yeah, now it's 100. So probably I missed something in this part. So now what happens? It starts as a 5. So it's triggered here. It continues as 4. Then it's triggered here, and that's why I get 100. But then I'm missing something here from the logic inside here. Oops, selected too many things. So now if it's 4, right, it will become 4 here. It will continue as 2. Then if it's restarting from the scratch, it will be 2, not greater than 3, not equal to 3. Then, aha, okay. So this is if it's equal to 3. If not, it's going to continue as 1, which will just go here. Aha, okay, now I understand. I missed somehow this part first time. I thought this is like, for some reason, I thought that this was the else branch. So I thought this is not going to happen, but that this is actually going to happen. So that's why. Okay, now it makes sense. Yeah. Cool, so cool. Like literally a state machine. Yeah, so cool, so cool. I mean, this is my favorite switch of all the languages that I've seen so far. Let me see what you write, guys. Just able to make VS Code highlight syntax, but unable to detect syntax error. You're, let's say in this part, you are ahead of me. So I even haven't tried to run Zig locally. I just run it online because it was faster to just like start running it online, then install things and set things up locally. But I will definitely do that, of course, eventually. But I'm kind of like enjoying it so much to just like code for now that I'm doing it like still in the same way. So I haven't tried with Visual Studio Code. I also haven't tried with CLion. I'm going to try both locally, but haven't tried yet. Let me see what you say, Robert. You're kind of exploring the edges of Zig. Yeah, I'm just scratching the surface. So who knows what I will see in the future, and I will probably love it even more every day. They are mostly neat and no insanity like C has. Yeah, I mean, okay, I understand C. So it was made to replace assembly, that you don't have to write like 50 lines of code to just do a loop or something like that, and few ifs inside of the loop. So literally, they just like made something that is more human readable, that translates one-to-one to assembly. So, and it was like genius for that time. Like how many years already? Like 50, more than 50 years ago. But yeah, now in 2025, unless you have some really large legacy code base, I don't see why would someone choose C to use it in a production. Okay, for learning part. So if you want to learn assembly and then see how C improved it and how things work, then yes. But other than that, Zig is so much more convenient and safer to work with. I still haven't touched basically the safe part, because I heard about something that it forces you to error handle sooner, or maybe it doesn't forces you, but it allows you to do error handling as soon as you not sorry, error handling. I was about to say error handling, the memory, the location. As soon as you allocate something, you can make sure that there in the code you will be able to delocate. So I don't know, because I haven't researched the code itself. I just read some posts or something like that somewhere. So I still don't know how exactly it's done. But yeah, so I haven't touched yet that part, the safety part. Language reference you are going through literally shows you everything language has, so might be a bit complex. Yeah, they kind of compressed everything, so they skip a lot. So actually I'm enjoying it because it's like that. So it's not like too wide and that you have to spend days and days reading it. So it is more like essence and compress, and then you play with it, which is what I like to do. For more today useful showcase of the language Zinglings. Yeah, I will definitely check Zinglings like suggested before. Okay, you are responded to Nopanon. It either means the VS Code extension could not find the compiler, most reliable way to do so, etc. This will probably help me, thank you in advance. As any env variable and tel extension, it is env. Okay. Or you have to you have not installed wrong version of ZLS. Okay. The version needs to match ZLS, should have been installed by the extension on pop-up. Yeah, I've seen once you recommended this site, I went there and there are instructions how to install Zig, so I just like give it a quick overlook. So because I was thinking like maybe I will do it online, maybe live, not online, but live in the stream. So I didn't want to spoil. I'm kind of like avoiding to do anything outside of the stream because I want this to be like realistic as possible. But I will definitely do something off screen, like going through the things that I've already went through. So not in the way practicing project, that's okay, I will do live, but I will like do recap and re-watch my videos offline, because there is no point that I stream how I watch my own video or something like that. So that's what I meant. Okay, let's see the next thing. Yeah, this was very cool. The best part so far. Switch and even more. Semantically is equivalent for the following loop. They now do the loop to do the same thing. So I will not go into details about this, because basically this is a different topic, while loop. I already covered that, so maybe in the future, maybe I will do something like that, but practicing live, like I will do something in a loop and then convert it to a switch or something like that. Definitely worth exploring. What is the next thing? This can improve clarity, for example. State machines, yeah, like you said, Robert. Where the syntax continue. Next state is unambiguous, explicit, and immediately understandable. Yeah. Once you understand that it goes back, it's understandable. However, the motivating example is a switch on each element of an array, where using a single switch can improve clarity and performance. Okay, I'm not going to do this today because I'm already way over 1 hour, like 1 hour and 10 minutes. And this, I believe, would take some time to play with, and I don't want to just like do it just like quickly, because the time is running out. So I guess I will stop here. I'm not sure if I'm going to do this next time, or if I can do something that would make more sense. What is this, day 14? So maybe I will do tomorrow errors and stop with switches for now. Let me see, inline switch prongs. What is after? Yeah, a lot of things here. Yeah, a lot of things. This will take an hour on its own, and then the while loop. So I believe tomorrow I will do while loops. Errors. I was just looking at while loops. And then I believe on Monday I will either refactor the tic-tac-toe that I did, so that I do it with these things that I've just done after. So let's say to include the unions, the structs, the switching, the functions, so all these things that I first refactor the tic-tac-toe game into that version. And then if this, let's say if it takes me maybe 20-30 minutes to do so, not longer, then I might even continue. I will maybe convert tic-tac-toe into this game. You probably know it, guys, like 4 in a line, where it's like the field is I think like 12 or 10 by 7 or 8, something like that. And like it's a physical game, so you like have these pieces of circles that are not a circle, like plastical circle-like figures that you then throw into these channels and they fall down. So basically you have like a gravity element as well. And then you have to make a foreign line, it doesn't matter, like in tic-tac-toe. So you can make it like horizontally, vertically and diagonally in both ways. And then both directions, and whoever has the four is a winner. So I will see that I do something like that. Maybe depends how time it will take me to refactor the code and practice these things while refactoring tic-tac-toe to this more, let's say, advanced, I mean not so advanced, but better, a bit better version of itself. So if it doesn't take me a lot of time, I might continue on the foreign line. If not, then in the next time I do like recap and practice, I will do foreign line. Let me see what you guys wrote before I go away. Where we stopped. Robert, it would be nice to do it online so other people can replicate it. Yeah. So I think you're referring to installing Zig. Yes, definitely. Yeah, that's a good idea. Nopen says thanks to you, Robert. Hope it helped. I also recommend to enable. Not sure if it's on by default. Showcase of inferred types in code. Okay, I will definitely then play with the extension with the linter in Visual Studio Code to see what are the options. Okay, so let's say if I do tomorrow, the 15th day, I will do errors. So then on Monday, I will do this recap, maybe in the normal, like this time, approximately Monday. I can install Zig before moving forward. I can install it locally, and then we can do it in a stream so that we go through the options, like installing it with C Lion as well, not only Visual Studio Code, and Visual Studio Code as well. And we can go from there. Okay, cool. Thanks guys for today. Have a nice evening. Have some fun. It's a weekend. I mean, for me, this is also fun. I will not go out. And see you tomorrow. That would be everything for this evening. Here it's evening. So see you guys tomorrow. Bye bye.